Welcome everybody. Today we are going to talk about a concept in C++ called a struct, which is short for structure. A struct is a way of creating a container for multiple variable types. And this is very, very useful when we need to represent things on the screen, in our case, or more generally sort of objects in our program. So you can see that I've got some of the code that we worked with in a previous class here on screen. And one of the things that I want you to get used to doing at the beginning of all of these videos is creating a new sketch. So I'm going to do that in front of you. I'm going to go File, I'm going to go New Sketch. I've got a new sketch here. So I'm going to copy out all of my setup and matrix stuff from my old sketch to my new sketch. I'm going to replace the setup function, and I'm going to paste it in here. So I've got all of my stuff to create my matrix up here. I have my setup function that initializes the matrix. And then I've got my loop where I can start to program. I'm also going to get rid of this string.h. We were using that to print strings to the console. I'm going to get rid of that. I don't need it in this program. And so now I've got a nice empty sketch that's going to let me start to program my matrix. So I'm going to save this sketch. I'm going to save it as, I'm going to give it a descriptive name. One of the things that you can't use in Arduino for some reason is spaces, so give it a descriptive name without spaces. I'll call this struct underscore test2. This is actually the second struct test I've done. So I'm going to save that. It's going to get me back to the same place. So now I've got a named sketch that I can start to work with. So previously, when we wanted to draw a pixel, what we had to do is create separate variables for the various attributes of the pixel, right? So it would have an x, let's say it's at 3, it would have a y, let's say it's at 7, and then it would have a, maybe we want to specify the color, so R, this is going to be a white pixel. It's going to be an off-white pixel. You can't really get true white with these, but you can get a color that's close. So this is all I need to draw a pixel, and if I wanted to draw this pixel, I would just say matrix dot draw pixel, and I would pass in x, y, and then matrix.color 565, and then I would pass in R, G, and B. This is something that you've all done before. If I upload this to my board, which you don't have to do, you've done this before, it's going to draw a single white pixel actually it's not going to do anything. I'm looking at my board right now. It's not going to do anything because I forgot the matrix.show. So now when I upload this, it's going to draw a single white pixel at 3, 7. And I'm just going to verify that that's actually correct. Again, you don't have to do this. You've done this before. So this gets really unwieldy when you start to work with multiple pixels. Either you have to make a separate set of variables for each one and call it x1, y1, r1, stuff like that. That's not very good. Or you create arrays for each property and you draw the pixels by sort of slicing across the arrays. But there's actually a much better way to do this, and that is to use a type of object called a struct. So the way you write a struct in C++, and a struct is like you're creating a new variable type when you create a struct. So I said there are integers, there are strings, we've got floats, there are some other types we haven't really talked about. When you write a struct, you are creating a brand new variable type that is a container for other variables. So the way you do it is you type in struct, and then you give your struct a name. We're going to call our struct particle. It should start with a capital letter. That's a convention. Open curly brace, and then you say all of the attributes that your particle has. So our particle is going to have an int x, it's going to have an int y, and attributes just means variables. It's going to have an int r, it's going to have an int g, and it's going to have an int b. You also have to put a semicolon at the end of your struct definition. It is unusual in C++ to have a semicolon right after a closed curly brace, but that's how you do it in structs. So now, and you'll notice these aren't, if I try and compile this, it's going to give me an error because x and y don't exist as sort of free variables now, right? I got rid of those definitions, and every struct, every particle I create is going to have an x and a y inside of it, but I haven't made one of those yet, and you have to get to those variables in a little bit different way. So when I create a particle, it's going to be just like other variable definitions where you type the name of the type of the variable, which in this case is particle, and then you give your variable a name. So I'm going to call, typically you'd call it something like my particle, but that's a little bit confusing, so I'm going to give it an actual name. I'm going to call it Frank. And then you can initialize it with a value, and since it's got a bunch of different numbers inside of it, you have to use curly braces. So if I want my particle to have an initial value of 3, 3, which is the x and the y, and these go in the order that you declare them in the struct. So this first one goes into x, this second one goes into y, and the next three are going to go into RGB respectively. Let's do a green one. I'm going to do 0, 2550. That's 0 red, 255 green, 0 blue, and then a semicolon at the end because it's just a normal line of code. So now I've got an object called Frank of type particle that has multiple properties inside of it, multiple variables inside of it. So the way I access these variables is by saying something like this. I'm going to write this line of code because I can't write and talk at the same time. RGB. So what this says is I'm calling the drawPixel function, and I am passing in Frank's x, Frank's y, and then inside of the matrix.color565, which is a function that packs these three numbers together in one number. That's, for whatever reason, that's how the drawPixel wants to see it. And I'm passing in an RG, Frank's R, Frank's G, and Frank's B, right? So this little dot operator right here, you use when you are accessing a variable or sometimes a function that belongs to another object. So every particle has all of these variables. Frank is a particle. So Frank has an X, a Y, and an R, a G, and a B. I am going to upload this to my matrix, and I should see a, oh, I forgot a semicolon. That is really easy to forget. So now I'm going to upload this to my matrix, and I should see a single green pixel at 3, 3. I do see that, and at this point I'm going to ask you to please go ahead and get this code into your Arduino and upload it to your matrix to make sure that you've got everything right. So once you've done that, one of the reasons that we use things like structs is it makes it really easy to create more complex objects. So let's say I wanted to have a bunch of different particles. And I want to have them at different places. And maybe with different colors. I'll just hit the full screen button. There we go. And now normally your variables aren't going to have human names, but I wanted to avoid calling it something that had particle in the name just so it becomes much clearer what's going on. And Annie is going to be red. Okay, so now I could draw each one of these particles, and I would have to do it in basically the same way by passing in, let's see, Jerry. And you'll notice these all have the same properties, so I'm just changing the name of the object that I'm looking up the properties from. And so this is going to draw my 3 pixels, and I'm going to go ahead and ask you to upload this code as well and make sure that you are getting a get this code into your Arduino, upload it to your board, and make sure that you've got 3 pixels in a diagonal line that are it should be green, blue, and red respectively. So I'm going to do this, and that's exactly what I see on my screen. So one of the things that I want you all to get in the habit of doing is when you start to write the same code over and over again, and it's long and it takes a lot of lines, you should start to think to yourself, there must be a better way to do this. I should be able to put this in a function or in some sort of object to make it easier. And you'll notice that drawing a struct, drawing my pixel or my particle, looks very similar every time. So I can actually make a function to draw a particle to the screen. The way you do this is you write a standard function definition. I'm going to call it draw particle because that's my object name. And you allow it to pass in a particle argument. So the way this would normally look is I would say the type of variable I'm passing in, and then I would give it a name that it would have inside of the function. Now, since particle is a struct, which is a user-created variable, I have to tell the C++ compiler that particle is a struct. So this looks just slightly different from normal function definition, but not a huge amount. So instead of just the variable type and the variable name, I have to add the keyword struct in front of the variable type. So now, then again, that is a variable declaration that exists inside of the function. And so when I enter the drawParticle function, I will have to pass in a particle, and I will have access to a particle named toDraw inside of that function. So I'm going to copy this line of code, and I'm going to paste it down here. I'm going to even up this tab. And now my particle is called toDraw inside of my function. And so I'm going to replace all of the Franks with 2 draws. And so now when I call the function draw particle and give it the name of a particle, it will draw that particle to the matrix. I'm also going to have it show that immediately so that I don't have to manage showing the particles up here. Now, there might be a reason you don't want to do this. If you are erasing a particle, you wouldn't want to show that immediately. You'd want to erase, draw, and then show. Because if you erase and show and draw and show, you're going to get flicker on your screen. But this makes the code in my loop look a lot nicer, because now I can say, I can just call my draw particle function and pass in a single particle. So I've got these 3 particles. I don't need this matrix.show line anymore because my draw particle function is handling that. So when I upload this, I'm not going to get any different output on my screen, but the code is much, much cleaner. And this is going to actually make it really easy to do animations and stuff like that, because now I can just change the properties on these individual particles and move them around the screen without too much trouble. So in order to do that, though, if you remember, the basic animation loop is number 1, erase, number 2, update, number 3, draw, number 4, show and wait. So I don't have a way to erase a particle yet. So I can make a function to do that very, very easily. It's going to look very similar to draw particle. It's going to take a particle struct, and all I need to do to erase the particle is draw a black pixel at that particle's location. So I want to keep 2draw.x and 2draw.y, but for the colors, I always want to do 0, 0, 0, because that's going to blank out the pixel. So now I've got a user-defined object. I've got 2 little helper functions that make it really easy to manage some of the common stuff we do in animation, and it doesn't take that much code, and it's going to make working with these particles very, very easy. It's going to make it a lot easier than it was previously. So now in my loop, if I want to sort of implement the animation loop now, so I'm going to put that in comments. That's something you all should be doing. Erase old. Make changes. Draw new. And the 4th is show and wait, which happens inside of the function. So we're not actually going to see that except for the wait. So this is the part where I draw the new. I'm going to put that down here. This is the part where I erase the old. So I'm going to erase particle. And let's say I just want him to move to the right. This is something we've done a bunch. So Frank, to move it to the right, I increase the x by 1. The way you do this is frank.x equals frank.x plus 1. Jerry.x equals jerry.x plus 1. And Annie.x equals Annie.x plus 1. So this is just going to move my particles to the right, and then I've got to add my delay. I'm going to delay 200, give myself a little bit of time to see it. And the show is being handled inside of this function, so I don't need to worry about it. So this is very, very clean code that makes it really, really clear what I'm doing, and it makes it really easy to manage these objects. I'm going to go ahead and upload this. Obviously, I'm going to get an error. Oh, because it's called toErase now, not toDraw. I forgot to change that. And I'm going to upload it again. This time it works. And I look at my matrix and I see the 3 pixels moving to the right. Now, one of the nice things about managing these objects separately is I can move at different speeds, right? I can now start to get different behavior for these different objects. So when I upload this, Frank is going to move slowly, Jerry is going to move middle speed, and Annie is going to move very quickly across the screen. And then they're all going to disappear at some point. So at this point, I'm going to ask you to stop and get this code into your Arduino IDE. Make sure you've got it uploaded and working for you. Here, I'll make this a little bit bigger. I'll show all this code on the screen. You can pause, copy it over now. I just want you to get this working. We're going to do one more thing in this video, and then I'm going to give you a skills check. So having individually named particles is not particularly helpful. What we generally want to have in C++ or in programming is we want to have these in an array so we can loop through it using a for loop and not have to call all of the particles out by name. So the way you do that, it's pretty simple. Is you do the same thing. You say particle, and I'm going to call this one my particles. It's an array of, let's say, 3 particles. And so if I want to initialize this with values, you don't have to. You can go in here and do this manually. But if I want to initialize this with values, I need a structure where I've got, I'm going to do this just blank to start out with. So these outer curly braces are because it's an array. These inner curly braces are because each element in the array has multiple variables. And you can see it knows how many I need to put in there. So I'm just going to take the variables I've already defined, or the values I've already defined, out of Frank. That one goes in there. Out of Jerry, that one goes in there. And out of Annie, that one goes in there. So now these aren't named anymore. I've just got my particles sub 0, my particles sub 1, and my particles sub 2. So now this gets a little bit easier to write. I'm going to use a for loop here. I've got 3 items in my particles, and I'm just going to do my particles sub I dot erase, erase particle. I got to call erase particle, and I'm going to pass in my particles sub I for making changes. Now this I could do, this I might want to do differently. So I'm going to say Frank is my particle sub 0 now, dot x. And this looks a little bit weird, but just think about my particle sub 0 refers to a specific variable. And then that variable is a particle. It has a dot x plus equals 1. My particles sub 1 dot x plus equals 2. And my particles sub 2 dot x plus equals, let's do 3. Then I'm going to do this for loop again. And I'm going to draw particle. And it's not my particle. Yeah, it is. My particle sub I. And remember, my particles is the name of the array here. And sub I is going to give me first the 0th element, then the first, then the second. I've designed my for loops so that they're iterating across my entire array. This technique right here, where you have a for loop that iterates across an entire array, is very, very important. I expect you to be able to do this. So now I'm going to upload this again, and I'm going to ask you to get this code. Oh, this isn't going to work, and it's not going to work because I forgot a semicolon. I'm going to upload. I forgot another semicolon. Forget a lot of semicolons here, folks. Now it's going to work. I found all my semicolons, and it should do something very similar to what we saw the last time. Again, I am going to ask you to pause. I'm going to show you this code on the screen. I want you to get all this code into your Arduino and get it working. So I just want to recap. We've done a lot in this video, but it's all very important stuff. So the first thing we covered is the concept of a struct. A struct is a way of creating a container for variables that represents an object in C++. This is the syntax for declaring a struct. I could give it more or fewer attributes, or attributes of different types. These are just the things you need to represent a particle. We learned how to declare structs individually, which is by saying the name of the struct, how to declare a member of a struct, and then we give it a name. And then you can give it initial values if you want to, but you don't have to. We learned how to pass structs into functions, which is a little bit different than other variables. And then we learned how to create an array of structs that we can loop through and manage all at the same time. So what I would like you to do is I would like you to make your own particle struct. And I'm going to write this out as well. It's, I think, very helpful to see these skills checks written out on screen. I want you to make your own particle struct. Your particle struct should also have the concept of x and y direction. So you'll need to add some additional variables. You'll need an x direction and a y direction. And I want you to create an array of particles. And I want you to give each particle in your array a separate animation or a separate movement type. So what you'll need to do is remember the basic animation loop. You'll erase the old and you'll draw the new and you'll show and wait. This is going to work just like it is in here. But in the make changes, you will do something different for each one of these particles. So maybe one of them will move right, maybe one of them will move up and down, maybe one of them will move in a circle. That's up for you to decide. You all have done some pretty advanced programming by this point. So I'm expecting to see the particles do something more than just twitch back and forth. This is up to you. I'm going to say a minimum number of particles and different movement types is going to be 3. So that is it for this video. If you have any questions, obviously raise your hand. We'll take a look at it together. Otherwise, let me know when you're done with your skills check, and after you finish that, you are ready to move on to the next one.